We now focus our attention on algebraic expressions. This involves the study of exponents, polynomials, rational expressions, and radicals. Objectives: the students must be able to 1. Identify algebraic expressions, 2. Perform operations on exponents, 3. Determine which algebraic expressions are polynomials, 4. Perform operations on polynomials, 5. Factor polynomials completely, 6. Simplify and perform operations on rational expressions. Finally, simplify and perform operations on radicals. Consider the following square. If S is the measure of one side of the square, then its perimeter is 4S. The formula for the perimeter of a square is an example of an algebraic expression. An algebraic expression is an expression containing constants and variables together with operations. For example, 4S. This actually means 4 times S. 4 is a constant and S is the variable. The operation is multiplication. Another example is 2xy squared. And then the square root of the quantity x plus y all over 2. The exponent is a notation which determines the number of times a number is multiplied to itself. For example, the area of a square is s times s, which is equal to s squared. Here, s is the base and 2 is the exponent. In a more general sense, b raised to n is equal to b times and so on times b. We have n copies of b for positive integer n. For our discussion, let's consider integer exponents and real bases. We now go to laws of exponents. Number 1. Multiplying powers with the same base. Consider 2 to the third power times 2 squared. 2 to the third power is 2 times 2 times 2, while 2 squared is 2 times 2. There are 5 2's, so the answer would be 2 to the 5th power or 32. What do you observe? When we multiply powers with the same base, we add the exponents. In our example, 3 plus 2 equals 5, and hence 2 to the third power times 2 squared is 2 to the 5th power. In general, b raised to m times b to the n is equal to b raised to m plus n. 2. Dividing powers with the same base. Consider 2 cubed over 2 squared. 2 cubed is 2 times 2 times 2. 2 squared is 2 times 2. These 2's will cancel, so we have 2 raised to the first power, which is equal to 2. What do you observe? When we divide powers with the same base, we subtract the exponents. In our example, 3 minus 2 equals 1, and 2 to the third power over 2 squared is equal to 2 raised to the first power. In general, b raised to m over b to the n is equal to b raised to m minus n. 3. Power of a product. Consider the quantity ab raised to 3. This is equal to ab times ab times ab. Rearranging, we have a times a times a times b times b times b. This is a cubed times b cubed. In general, if we have the quantity a times b raised to n, this is equal to a to the n times b to the n. For example, the quantity 2x raised to 4. This is equal to 2 to the 4th power times x to the 4th power, which is equal to 16x to the 4th power. 4. Power of a quotient. Consider the quantity a over b raised to the 3rd power. This is equal to a over b times a over b times a over b, which is equal to a times a times a all over b times b times b, which is equal to a cubed over b cubed. In general, the quantity a over b raised to the nth power equals a to the n over b to the n. For example, the quantity x over 2 raised to the 3rd power equals x cubed over 2 cubed, which is equal to x cubed over 8. 5. Power of a power. Consider the quantity x squared raised to 3. It's equal to x squared times x squared times x squared. This is equal to x to the 6th. In general, b raised to m raised to n is equal to b raised to m times n. For example, the quantity a cubed raised to 9, 3 times 9 is 27, so the answer is a raised to 27. 6. Zero exponent. The rule is b to the 0 equals 1, where b is not equal to 0. For example, 2 to the 0 equals 1. Next, the quantity 3 over 5 raised to 0 is also equal to 1. 7. Negative exponent. This is the rule b raised to negative n equals 1 over b to the n, where b is not equal to 0. For example, 2 raised to negative 1 equals 1 half. 3 raised to negative 2 equals 1 over 3 squared, which is equal to 1 over 9. Let's go to the following exercise. Simplify the following expressions. Number 1, the quantity 3a squared b raised to negative 1 raised to 4. 2, 10r to the 4th power s all over 25r squared s cubed. Number 1, the quantity 3a squared b raised to negative 1 raised to 4. Note, b raised to negative 1 is 1 over b, so this can be written as the quantity 3a squared all over b raised to the 4th power. This is a power of a quotient, so this can be further written as the quantity 3a squared raised to 4 all over b to the 4th power, which is equal to 3 to the 4th power times a squared raised to the 4th power all over b to the 4th power. And the final answer is 81 a raised to 8 all over b to the 4th power. 2. 10r to the 4th power s all over 25r squared s cubed. Let's simplify the constants. 10 over 25 is equal to 2 over 5. For r to the 4th power over r squared is equal to r squared. And for s over s cubed is equal to 1 over s squared. So the final answer is 2r squared all over 5s squared.